For years, the world has been obsessed with clips of robots dancing, doing flips, and even just walking in studios. But those demos are effectively worthless if the hardware cannot survive a shift in a real factory. In late 2025, the gap between social media hype and industrial reality finally collapsed when Ubtech pushed the Walker S2 into mass production. They were not trying to build a miracle machine. They were building a tool for the tasks that are too irregular for the typical robotic arm bolted somewhere, and far below what a human is actually capable of doing. Before we look at the broader picture, we have to talk about the machine itself. The biggest misunderstanding in robotics is that these machines are supposed to be better than us at everything. They aren't. They are slower, heavier, and far less dexterous. But in a high-volume factory, being better doesn't win. Being consistent does. Take attention span as the first example. If you put a person on a quality control line for 8 hours, staring at the same door seals, their accuracy is going to drop. It's unavoidable. We get tired, we blink, and we get distracted. But the Walker S2 doesn't see like we do. It uses dual 4K stereo vision and LiDAR to scan for sub-millimeter defects with a level of precision that never flickers. It doesn't have a bad Monday, and its error rate at hour 1 is exactly the same as its error rate at hour 24. Then there's the issue of stamina. A typical human shift is 8 hours, but between lunch, breaks, and shift handovers, you're rarely getting 8 hours of pure output. The S2 is the world's first hot-swappable humanoid. When its battery gets low, it doesn't sit around waiting for a charge. It walks to a docking station and swaps its own battery pack in under 3 minutes without even powering down. That transforms it into a machine that can literally work a 168-hour week with very little downtime. When it comes to strength, the S2 targets the Goldilocks zone of manufacturing. It can lift and carry up to 25 kilograms. Now, that's not going to break any world records, but it's the weight that caused the majority of chronic back injuries on factory floors. It handles the repetitive, heavy lifting that wears down human joints over a 20-year span, and it does it without ever needing a physical therapy appointment. And it would be as good as new once maintenance is done to the parts that are worn out. Lastly, don't expect this thing to win a 100-meter dash. Its top speed is about 7.2 kilometers per hour, which is basically a brisk walk. But while a human slows down as the afternoon drags on, the S2 stays at that locked pace from the first minute to the last. Right now, Ubtech admits these bots only have about 30 to 40% of a human's total productivity because they still struggle with complex, fine motor tasks. But the roadmap is aggressive. They are betting that by 2027, that number hits 80%. When you combine 80% productivity with a machine that never sleeps, never complains, never gets sick, never takes a leave of absence, and never misses a defect, the picture starts to look very different. In late 2025, Ubtech locked in a massive $37 million contract to deploy a fleet of Walker S2 humanoids at the China-Vietnam customs. For the first time, a humanoid fleet is being tasked with the heavy lifting of traveler guidance, logistics flow, and patrols in a high-traffic, real-world environment. They aren't just standing there looking pretty. These bots will be actively patrolling corridors and waiting areas to monitor crowd patterns and flag blocked exits that a tired human officer might miss. The real breakthrough, though, is the uptime. While a human officer needs to eat, sleep, and rest during his shift, the S2 is equipped with an autonomous battery swapping system, the first of its kind. When its power gets low, it walks to a docking station, swaps its own battery in under 3 minutes, and gets right back to its duties automatically. This is the ultimate test of the AI employee concept. China isn't waiting for these machines to be perfect. They are betting $37 million that a robot that never sleeps is a better investment than the status quo. If this works, it's the blueprint for every airport and port in the country. For Ubtech, 2025 was the year they stopped showing off and actually started delivering. In 2024, they delivered a mere 10 units, which quickly scaled to 1,000 units in 2025. As we enter 2026, Ubtech is gearing up to manufacture 5,000 units by December, with a target of producing a total of 10,000 units in 2027. Ubtech's Walker S series is already working for industrial giants. BYD, Geely, and FAW Volkswagen have put them directly onto the production lines to handle high-precision quality inspections and parts sorting. These are the jobs that grind humans down, but the robots perform without any fatigue or complaint. While the rest of the industry is still arguing over how these robots should look and marveling over walking and doing flips, Ubtech has already moved on to the much harder problem of making them perform at work and producing them at an increasingly larger scale. Now, when you look at a 24/7 post, you aren't just looking at a job, you're looking at an industrial maths problem. To keep a single position manned 24 hours a day, 365 days a year, you need a minimum of 4.2 full-time employees just to cover the 168 hours in a week. But once you factor in sick leave, holidays, and the inevitable administrative overhead, that number realistically jumps to 5 or 6 people per post. For early adopters, this investment isn't based on a future dream. It's based on the cold, hard reality of today's payroll. Right now, a Walker S2 lists for roughly $100,000. That sounds steep until you look at the salary of the people it's replacing. In China, the average salary for a customs officer is roughly $27,000 a year. When you multiply that by the 5 people required to keep that post active through the night and weekends, you're burning nearly $135,000 every single year. And that's before you pay for their insurance, their pension, or the supervisor needed to manage them. At the current $100,000 price point, a single robot hits the break-even mark in about 8 months for a post that requires 24/7 work. Even with a 2-robot setup, you're looking at a $200,000 investment to replace a $135,000 annual human payroll. That means by month 18, the robots have paid for themselves entirely, and every year after that is pure cost savings. For a piece of industrial hardware with a multi-year lifespan, this investment is an absolute no-brainer. Because of the autonomous battery swap system, the S2 doesn't need a relief shift. It doesn't need a holiday. It doesn't need a manager to make sure it didn't fall asleep at 4 a.m. From the second year onwards, the cost of that labor effectively drops to the price of electricity and the maintenance contract. When you scale that across a border crossing or a massive assembly plant, you aren't just saving money. You are fundamentally breaking the relationship between more work and more payroll. In addition to the maths of breaking even, there's this principle in economics called Wright's Law. It states that for every doubling of cumulative production, the cost of making a product drops by a fixed percentage. It's why your smartphone doesn't cost $10,000. And it's exactly why Ubtech's jump from 10 units in 2024 to an annual capacity of 10,000 units by the end of 2027 is such a massive shift for the global market. Ubtech isn't just hoping for lower prices, they are engineering them. And Wright's Law isn't just a fancy way of saying things get cheaper. It describes a specific feedback loop: learning by doing. In general manufacturing, this learning rate is typically 15 to 25%. But in the robotics field, Firms like ARK Invest have found that the learning rate is actually closer to 50%. That means every time the total number of robots ever built doubles, the cost could effectively be slashed in half. This triggers a massive improvement in manufacturing yield. They aren't just buying more, they are learning how to build the machine with fewer, cheaper, and more reliable parts. To lock this in, Ubtech made a massive move in late 2025. They dropped roughly $239 million to buy a controlling stake in the company that supplies them with the parts to build their robots. By buying their supplier, Ubtech now owns the production lines for these core parts. This vertical integration is how they've already localized 90% of their supply chain. While many are still hand-assembling prototypes in labs and paying prototype premiums for every motor, Ubtech is using the sheer might of Wright's law to lower the price of their robots. Racing to bring that unit cost down from $100,000 towards the $20,000 target by 2030 through sheer, relentless volume and optimizations. And while the rest of the world is busy filming demos in studios, Ubtech is running a massive, real-world experiment that looks more like agile software development. In the tech world, it is called ship to learn. You don't wait for the product to be perfect. You put the minimum viable product into the wild and let reality break it. In late 2025, Ubtech locked in the contract to deploy a fleet of Walker S2 humanoids. This isn't some clean room pilot. This is a high-traffic, high-chaos environment where robots are being tasked with guidance, logistics, and perimeter patrols. By deploying now, even while the S2 is only hitting about 30 to 40% of a human's productivity, China is turning the border into a giant, living testbed. Most of the industry is obsessed with synthetic training, running millions of simulations in a virtual world. Don't get me wrong, the pros are huge. It's a lot faster, costs less, and you can crash a billion virtual robots without scratching the paint of a real one. However, there is the sim-to-real gap. The gap that exists because the simulation can't perfectly mimic the real world. Therefore, real-world training is the only way to solve this last mile of training. Every time a robot trips on a curb, glitches in a crowd, or fails a cargo scan, that data is fed straight into their BrainNet 2.0 platform, straight into the hive mind. They aren't just testing hardware. They are using real-world failures to refine their AI in real time. This creates a feedback loop that no laboratory simulation can ever replicate. While Western models often keep humanoids in controlled pilots for years out of caution, the Chinese strategy is to iterate in public. They are effectively using state infrastructure as a massive R&D facility to solve the last 20% of the humanoid problem. By the time the competition is ready to launch, Ubtech would have already spent years learning exactly how its fleets behave when they actually have to work for real, and not just do flips for the cameras. But the real unfair advantage here isn't just that they're out in the wild. It's the hive mind effect. Ubtech's BrainNet 2.0 is essentially a distributed cloud brain. When you deploy a fleet of 1,000 robots for a single year, you aren't just getting 365 days of data. Because every single unit is feeding its experiences back into the same central model, you are effectively downloading 1,000 years of experience into the hive mind every 12 months. Now, a lot of that data is redundant. A robot walking down the same hallway 50 times doesn't teach the system much new. But in the world of AI, data density is everything. That boring duplicate data allows the system to filter out sensor noise and perfect the baseline movements. Meanwhile, the edge cases, like a wet floor at the customs gate or a child running in front of a robot, only need to happen to one robot for the entire fleet to learn how to handle it. This is the network effect applied to physical labor. While a standalone robot is only as smart as its own history, a Walker S2 is as smart as every mistake every other Walker S2 has ever made. By using the China-Vietnam border and factories as massive training grounds, Ubtech is building a superbrain that would have seen and solved more real-world problems than any lab-bound robot could encounter in its lifetime. They aren't just shipping hardware. They are accelerating the evolutionary timeline of its robots. The China-Vietnam border pilot doesn't prove that humanoids are ready to take over the world. Far from it. In fact, if you saw one of these things struggle with a heavy suitcase or glitch out in a crowded terminal, you'd probably think the hype was premature, and the whole thing is a costly joke. China isn't waiting for a breakthrough moment where a robot suddenly wakes up and becomes human. They are betting on the compounding advantage of two things: manufacturing learning and operational learning. Every month the Walker S2 spends on that border, it isn't just getting cheaper to build, it's getting smarter at navigating and interacting with the real world. Right now, an S2 might only hit 30 to 40% of a human's productivity. That sounds like a failure, until you realize the S2 is essentially a data harvesting machine. By shipping the S2 into the wild today, Ubtech is effectively force-feeding the development of their next robot. Every trip over a doorstep, every sensor blinded by the sun, and every actuator that overheats is a direct input for the next generation. They are doing real work to get real results. This is the start of the humanoid decade. If you want to know who's actually winning, watch if this expands to other ports. Watch how fast the next iteration of their robots drop. And if Ubtech hits that 10,000 unit per year target by 2027, that results in the cost curve becoming something that the rest of the industry cannot ignore. The S2 isn't a final product. It's a minimum viable product that doubles as a lesson for Ubtech. And in the world of global robotics, the one who learns to swim in the rough water first is the one who eventually owns the ocean. The million-dollar question is, are they actually there? Or is it all just boastful propaganda? The fact is, they have been reported to be delivered. So, it is expected that they would be deployed, however slowly but surely. Since the S2's job is public-facing, there is no longer a need to rely on the press releases. You're going to see videos from travelers with these robots. If this is an expensive flop, there will be proof of it in video. And if it is a huge disaster, the robots will likely vanish.